Okay, good morning, everyone. We're doing yet another live stream. We've done a series of these over the last several months now, and you can catch those on YouTube. We'll be putting a link. And of course, like we always say, please join us on our Discord server so we can continue the conversations, the great conversations we have in these live streams. So with that, I'd like to introduce today's guest. Today's guest is Prateek Jain. Good to see you, Prateek.
Thank you. Thank you for having me.
Absolutely. And so Prateek's been working on our fast, accurate, hyper-personalized search mechanisms. And it's actually a pretty sophisticated pipeline. I'm not sure how much of this we're going to talk about today, but what I'd like to do is maybe just demo to people what we've done and why it's special. I know between hybrid search, a lot of the structured embeddings that you've been creating, the fine-tuning you've been doing, there's just a great many different sort of achievements that you've been carrying forward over the last few months. So where do we want to start today?
Maybe we can have a small demo of how our search works, semantic search.
Okay, sounds good. So let's before you kind of show us something, it looks like you're bringing up the app. What I just want to say is that we've gotten used to a certain type of search, which is sort of a blue link search. You look for specific keywords and you get results back, and you start to click into those links to actually see what you want to see. That's kind of a blue link search. And now what's happening is increasingly we're starting to see conversational search. And now as people take action on those search results, we're starting to see that search is no longer just about retrieval and answers. It's also sort of the laying the groundwork for agentic behaviors, especially in the enterprise. So I think this is a particularly good topic for us to discuss today.
Definitely. Yeah, it's becoming important and it's more conversational in nature now, which we would demonstrate how our search is very conversational in nature.
Yeah. So maybe we start with something here. You want to show us a specific search and we can start to look at the anatomy of the results?
Yeah, definitely. So I'll talk to our search agent now, and I'll show. Let's ask it a question about my own issues.
Okay.
So I'll ask it something which doesn't have the keyword I'm looking for because it is semantic in nature, and it should be able to show me the right things.
Okay.
I'll ask it for my completed issues, let's say on improvements in vector search.
Okay. Sounds good. And as you're typing that, obviously we support both keyword, what you would call syntactic search, and as well as traditional semantic search, which means that we understand what the person is saying with the language that they're using because we understand relationships between words.
Yes.
So you're saying, show me my completed issues on improvements in the vector search. Okay. See what comes back. And now this thing's going to actually go and try to figure out what type of issues there are in the system, and it tries to understand what my means, and it tries to understand the nature of the topic that you're asking about. And we've got several results here. It looks like you've been doing a lot of work on vector search.
Yeah, so that has been the topic I've been primarily working on recently, and it actually pulled up the right issues that I've been working on. And it actually knew without telling that, okay, maybe fine-tuning helps with improvement, and I'm talking about embedding models, even though I didn't use those keywords. If you look at all the search results, they are about fine-tuning or improving embedding models for different use cases.
Okay, fantastic. So now, I mean, it looks like you've got several results back. Can we start to think about how we evaluate ourselves to see if we're truly giving back the right results? Is there some sort of measures and mechanisms that you use to kind of think about that? What are the KPIs, for example?
Yes, so we extensively evaluate our embedding models, which we use for semantic search as well as retrieval in general. And there are a couple of metrics that we track before making any changes and for any kind of improvements that we want.
Okay.
And maybe I can show you a graph or so about the metrics that we track related to some of the models that we use or we have used. How about that? And we can discuss about those metrics.
Sounds good. Do you have something ready?
Yes.
Okay.
So yeah, we have been tracking our retrieval eval, and here are a couple of charts. So one of the most important metric that we track is recall at k at different points. So it basically says that in top 5 results, top 10 results, how many of the total answers that should have been present are actually present. Now this is a very important metric to track because every search has a fault line, and every user loses track of things if they don't get the right results in, let's say, top 5 or top 10 searches. So we track it at every different point: 5, 10, 15, 20, 25, and so on up until 100. because we want to give the most accurate results to our user, even if it is being served directly or if it is going through a re-ranking pipeline.
And this is super interesting because you start to see some at some point people are going to stop scrolling. So in a traditional keyword based search experience, which maybe later on you'll show us that as well. Obviously you showed us the semantic search or the conversational search today. You're going to get a certain number of results before you have to start scrolling because there's only so much screen real estate, no matter what kind of machine you're on. And number two, even in a conversational experience, you're going to send back a certain number of results in the result set for it to be sort of transformed into a conversational response. So even there, if you're not in the top 10, 15 results, you may not be part of the actual response that the answer that the human gets back. So I can see that. I mean, in the conversational search example that we just looked at, well, were you returning 15 or 10 or 20 results? What was K?
Yes. So in this case, we were returning 20 to 25 results here,
Okay.
but it really depends on the use case that we are serving. So at some point, we might just want to return 5 results. It's really we hyper personalize for things we are searching for. So
Hmm.
number of K depends on that, and we do this analysis for every different kind of use case that we have.
Okay.
So as you mentioned that we have a limited real estate on screen, so people tend to lose interest if we don't serve the right results to them. And if we serve let's say wrong 100 results to an uh, agent that they are talking to, it might not perform as well as it might perform if we give the qualitative results in, let's say, top 10 or top 15
Mhm.
things that
And
we are doing.
and in order to sort of discover the right sort of insights, what else are you looking at? So we understand the recall at K, which really is about if given 5 shots at it or 10 shots at it, 20 shots at it, can we find the absolute best result for the human? What other metrics are there that you're paying attention to?
So apart from this, there are a couple of other metrics that we track, which is precision at K and NDCG at K. So
Okay.
precision at K basically tells us that, okay, within the top results, this is the amount of purity that we have in results, and this is the amount of noise that we have, which is very important because whenever we pass something to an LLM, we want it to receive the best of context. So these metrics become very, very important for us to track. And again, we track it at every step and every different possible K that we can pass without compromising on latency.
Got it. And so, how is precision calculated? Once more, can you just be specific about how the calculation is done?
So precision is essentially, let's say we are fetching top 10 results. How many of those top 10 results should actually give the answer for the question that user has asked? So
Mhm.
it's a percentage over your K. How many of them are actually correct and should be passed in context? So
Got it.
that's my precision.
Okay, and the other one?
Other one is a rank sensitive metric, which tells me that how many of them should have been in top, let's say 5 or 10, and which are not there and down in the rank. So it penalizes the results which are down and give me a final normalized score after those penalization. So better the score, higher, better is the rank of our results in the retrieval.
Okay, and can you zoom into that one? It just seems like it's literally a horizontal line. So trying to understand what that means.
So it means that after a certain point, the essentially this metric has been designed to be rank sensitive, and after a certain point, let's say after 20 results or 30 results, it really doesn't matter because no one actually scrolls to that point or reads up until that point, or even that point is not important when we are feeding context to an LLM. So all that matters is top 5 to 10 results that we feed to an LLM, because up until that point is where the rank matters, and that is what NDCG also captures.
Got it. Okay, sounds good. So we looked at a few metrics. Where do you want to take it? Obviously, if you're going to be talking about metrics, you're I'm sure doing some sort of synthetic benchmarking.
Yes, yes. So we do have strong data sets to evaluate on. Maybe I'll show you the data set that we have been working on and
Okay.
how we do our evaluation. Uh,
Okay.
so, so on your on the screen, you can see that we have a validation data set with around 78 queries, where on the left side we have the query which is an actual query that user has asked our platform, and on the right hand side we have the corresponding ground truth. Ground truth are nothing but information nuggets that should be answering that query. We have a proprietary method to do this annotation.
Mm-hmm. Mm-hmm. And so how often are you creating these data sets? How often are you running these tests?
So we do it periodically, let's say every month or so. So we don't have a fixed schedule for it. We do it based on how much data or new data comes into picture, and how much our distribution is changing, because
Mhm.
we want to stay up to date with this.
And I'm sure it's also, and by the way, guys, we're getting into a lot of really interesting details. Obviously, we didn't spend nearly enough time on the metrics. If you guys want to continue this conversation with myself or Prateek and others on the team, you can join us on the Discord server. So I think Nimit can put that on the screen as well. And you guys can save that link. Coming back to the data set, I mean, I'm sure it's also a function of how often you're actually changing the algorithms behind the scenes as well, right?
Yes. So if our algorithm changes or if our use case changes, so does our data set. So we have data set specific to each use case that we are trying to serve. So
Mm-hmm.
this particular one is for retrieval, that we, for a given query, can we retrieve the right nuggets which would answer that query. And maybe I can show you a sample of the query and the nuggets that we have as an answer for that.
Sure, let's do it.
So for example, this is our first query, which is asking about configurable sender name in email. Can you do that in DevRev? And below that, you can see four different chunks that are answering that question in a slightly different manner or with slightly different information. So we
Mhm.
need all these chunks to be able to answer this question holistically. So that is the level of precision we go to answer each question in our app.
Okay, and in the application experience, depending on the use case, what you're saying is that not only are we going to take these four chunks and rather than just sort of picking which one we want to show, we're going to actually amalgamate the results and come up with a holistic response.
Yes, absolutely.
Okay,
Yes.
sounds good. So what do you want to show us next? So we've seen some of the metrics. I guess you were showing that to us on a weights and biases dashboard.
Yes.
Here you're in a Python notebook, and we're looking at how sort of the anatomy of the data set. Obviously, we saw the semantic search that you did to begin the conversation. Where do you want to take us next?
Maybe we can show how our hybrid search looks like, because semantic search is not the only thing that we do.
Yeah.
We do have hybrid search in place.
Okay. Let's have a look.
So this is how our architecture for hybrid search looks like. We have a syntactic search, or what we would like to call as keyword or prefix based search in place, as
Mhm.
well as semantic search. And this entire thing is being we are using OpenSearch to manage this entire infrastructure.
Okay. And I think next week we're going to have another live stream where we're going to go in detail into what it took for us to be able to use OpenSearch. Obviously, it wasn't ready from day one. We used to actually have our own vector database. And for a variety of reasons, there were features that we were hoping for that we worked with the team on to actually get them to a point where we could adopt OpenSearch freely. And we'll talk about that next week. But I think it's really interesting for people to understand that like keyword search continues to be very prominent in the enterprise. And so we have a way to sort of reconcile both keywords and semantic to give a really good search and retrieval experience. Can you talk a little more about how this comes together? Is there an example you can show, for example?
Yeah. So as you mentioned, keyword search is still very relevant. Reason being, a lot of times people know exact words that they want to search. So at that time, apart from semantic search, keyword search also turns out to be very useful. And we have a proprietary method to blend results from both of them, and then pass through a reranker, which we will be talking later. But I would like to give you a demo of our keyword based search, of how it works, and again how recall there matters.
Okay, let's have a look.
Let me go to.
I mean, while you're pulling that up, what we found increasingly is that search is becoming sort of what I would call it an orchestration layer, because when you're in a conversational experience with an agent, you often are searching for information to sort of create the basis for the action you're going to take. So number one is to have access to your enterprise's structured and unstructured data on a familiar surface, a conversational surface. So that's what we've been looking at. But increasingly, and we'll talk about this in a subsequent live stream, what happens is people are doing searches to get answers, and then they want to take action. And it's that sort of that basis that you get when you do the search, which becomes the orchestration layer for the actions that you're going to take. You may take actions on specific records. You may take actions on specific collaborative experiences. And that's what's fascinating about sort of search in this modern era, is the fact that it's really orchestrating sort of the next best action that a human wants to take. So, but we'll leave that for a subsequent live stream. Is this now a keyword search that you're doing, Prateek?
Yes, yes. So as you can see, there's a fault line available, and that is the case with most search algorithms. There's up until a certain point where people would look at, and after that, it becomes increasingly unlikely that they would like to go further. So here
Yeah,
as
so
well.
we're seeing 6 results here. What you're really saying is the likelihood that people are going to keep scrolling in this experience is very, very low.
Yes, yes. So what we want to do is to serve them the best results within the top 5 and top 6 here, which is
Yeah.
what happened. If you can see, all of the keywords matches the issues that showed up here.
Okay. Fine tuning embedding model. I gotcha. And this is entirely keyword. There is no semantic in this result.
No, no, there's no semantic here. Because we want to give people both experience, a keyword search as well as a semantic search experience, we blend semantic with bit of keyword as well as I told earlier, to give them even a better experience in our agent.
Got it. Okay, perfect.
So maybe as we are talking about semantic search, would you like me to deep dive into how we embed things, how indexing works here?
Yeah, let's have a look. I maybe we can look. Starting with an example. If you have like an article or an issue that we can look at, and then see what it looks like if you break it down into chunks and then further embeddings.
Absolutely, absolutely. So I have the right thing here in place. I have a sample article opened up, and go through the process that we do to be able to store this information in our vector DB, and
Mhm.
then maybe we can do a search to see that whether this article shows up and has it already been embedded in our vector DB or not.
Mhm. So
So
just to give people a little more color on what we're seeing on the screen, we've got a split screen here. On the right-hand side, you've got the DevRev web app open, and particularly we're looking at a side panel with an article, and that article has to do with troubleshooting synchronization discrepancies. It's actually written by Dragoslav. We can see what part it's associated with, and there's obviously the problem statement and probably a great amount of text that's sort of uh, written down here. Perfect. So we've got a nice article here, and what we're looking at is how does that article become a series of embeddings that exist inside our vector database. So let's have a look at that.
yes. So as you can see on your left hand side, there's a diagram demonstrating of what happens. We take an article, then we chunk it down into semantically relevant pieces. For example, if we look at this article, we would have different chunks. Let's say first chunk would be starting from the problem statement. Second one would be talking about the root cause. Third one about the solution, and so on. So we try to chunk them into the right pieces before we even embed them.
Yeah, and I mean, I know there's a lot of structural, topical pieces that actually get added to the chunks. It's not just about breaking it down into sort of a sequential set of chunks, especially if you've got articles that have images and other things going on as well. Obviously, subheadings and subheadings below subheadings. So I suspect there's some other work that's happening in terms of creating the embeddings, which you're probably experimenting with. I'm not sure how much of that you can actually go into. Some of that is quite proprietary, obviously.
Yes, quite a bit of it is proprietary, but we do contextualize our chunks a lot, and we do a lot of pre-processing to make them as better as possible and to give out as much information as possible.
Yeah, and I know you're also obviously not only experimenting with different embedding models like you showed us earlier, but at this point you're obviously also looking at fine tuning embedding models so that we can understand sort of different verticals on different organizational behaviors, terminologies, and actually do a much better job of creating embeddings so that we better understand the material that we're actually embedding. Is that correct as well?
Yes, yes. We are trying to bring personalization even on embedding level, and that's what we are working with right now to serve each different devog with the right model suited for them and for their use case.
Yeah, but let's leave that for maybe a separate discussion, maybe a different live stream. So the fine tuning of embedding models and being able to serve that effectively and efficiently, that'll be a separate topic. But now let's suppose that we've taken this article and we've created the right embeddings. And obviously we've done this on every subsequent update on the article. And we've been doing this for all articles and all objects in the system and also all the unstructured content. And now we've created this vector database. Can you show us what search looks like on top of this?
Yes. So let's go back and maybe ask a question related to this. So the article was about Jira synchronization issues.
Mm-hmm.
Let's ask it if we can find that article.
Yeah. It'd be good if you did a misspelling just to kind of show that it still works. Yeah, just remove a couple words or something. There it is. Yeah, a couple of letters. I like the fact that it gives you like a thinking trace, so it actually you know exactly what it's doing. It's going through the articles. It already knows to look at articles because you've mentioned articles. Now, if you had not mentioned articles, if you had said, "Are there any published docs?" would it have known to look at articles?
Yes. So the reason I mentioned article specifically here is because we wanted to show that this particular article has been embedded. If we have had not mentioned is there an article, it would have rather given you a holistic answer. So yet it would have answered from the same article, but just to pinpoint that it was able to find an article related to that, we phrased the query this way.
Okay, but of course you could have not you could have left out the word article entirely.
Yes, yes, yes. And it would have still given me the right answer.
Okay, perfect.
And
You're in luck. Now it gives you an answer. And actually, that first bullet point is precisely the article we just looked at.
exactly. And
Okay.
this also demonstrates how good our recall and precision is, that we got the right article at the very first thing without even needing to scroll down.
Very nice. Are there certain things that trip you up? I mean, of course, here you talk about Jira synchronization. Yeah, and it doesn't matter that you misspelled it; it still kind of aligned it. Are there ways? Can you demonstrate something where you would have maybe not necessarily seen it as the first result? If you had said, like, what would it have taken for you? Because it's not like you mentioned much, but whatever you did mention was in the title. Let's suppose you were looking for something more specific that was perhaps in the body of the article. Could that have led to a result where maybe that specific article would not have been the first one returned?
So it really depends. If we have that information distributed across the articles, then it might not have given the same article as first, but rather given me the answer to the question that I've asked right over there. So it is not necessary that only one article is answering that question, because what we have is a knowledge graph, and
Yeah,
we do a multi-hop over articles to give back the right information. Since here,
maybe we can do it like a live experiment. If we go back to that document and if we actually search for something that's in, so merging user accounts is one thing. Root cause: when Jira does not provide an email for a user, creates the user with a placeholder. Okay, so why don't we ask a question? Do we have an article about merging user accounts from Jira and see what happens? So yeah, do we have any articles relating to merging user accounts from Jira? Users, yeah, accounts from Jira. Let's just see what happens. And I love the fact that we put the question mark, even though the question mark probably has absolutely no bearing on the result.
yeah,
Okay, so it's gonna go back through. Oh wow, is that the first one?
yeah,
Okay, so it still works really well. So it's not just some sort of a topic or title gimmick.
yeah.
Yeah, this is perfect. Let's just see what it says. Provide the step-by-step guide for merging duplicates or shadow user accounts in DevRev that result from Jira sync issues. Okay, fantastic. I love it. So now, I mean, we've looked at semantic search, we've looked at syntactic search, we talked about re-ranking, we talked about the metrics, the data set generation. Let's talk about personalization.
Mhm.
Okay.
Definitely. So we have a very strong personalization component in our search. Maybe I can go over its architecture right here so that we can deep dive into it.
Okay.
So this is how our re-ranker component looks like. We fetch syntactic and semantic results from different places, pass it to our re-ranker with our user query, and we have different components ranking articles that we have fetched with different criteria and trying to serve the best personalized result to a user. It is based on object rank, query object similarity, as well as user object similarity.
Okay. Can we see it like I know we talked about this before the live stream started, but we were talking about if you just created two different issues, but they were assigned to two different people, or they were maybe created by two different people, would it actually have a bearing on the search results? So could you show us maybe a demo of something like that?
Definitely, definitely. Let's do that. Okay, so I've already some text for some sample issue.
Okay.
So let me use that. Otherwise, it'll take a lot of time to.
Yeah, we don't want to sit here typing all of that.
Yes.
Okay.
So I have,
Improving embedding. Okay.
and I have. Sorry.
Seems like even in your examples, it's all about embeddings and fine tuning. You're really married to this topic. I love it.
Yeah.
By the way, those diagrams, man, just maybe some color next time, perhaps.
Yeah. There'll be more. They'll be more colorful next time.
Okay, that was good. I love the way we show the parts, by the way. Like it just shows you sort of the relationship between what we're doing and what we're serving. It's wonderful. Anybody who has not used DevRev, please, for the sole use of parts, I think it's worth it. Okay, so you've created an entire issue here pretty quickly. You want to create that real quick? And
Yes. So now let's do it for a colleague of mine.
okay, so we're gonna create the same issue again. Yeah, okay. That's a pretty suboptimal the way you did it. I thought you would paste the description first so you didn't have to copy twice.
My bad. I just realized after I paste.
That's a very nerdy thing to note, but that's just how my brain works. And so this is going to your colleague Prakhar.
Yeah.
Okay. And I guess we will delete these issues later on. Is that right?
Yes. Yes. Yes.
Awesome. So we've created literally two identical issues. Obviously they're identical, but they're two distinct issues. They have their own identifiers. They're assigned to two different people, and perhaps they get moved to different stages, have different priorities. This is like a living and breathing system of record. So people can do whatever they want. They can add collaborative discussion topics and threads and attachments and what have you. But before anybody does anything with these two, they look pretty darn similar, and they were created one after another. So there shouldn't be too much of a recency bias either. But what is different is the fact that one is owned by you and the other is not. So let's see how that actually has an implication on search results and ranks.
Yes. Let's do that. Let's search for the keywords here. Fine tuning. Embedding model.
Mm-hmm.
And if you look at it, it first of all showed all the results that are relevant to me. So these are my actual issues that I have worked on. And the one that I've created here has showed up here.
Okay, so the one that showed up there on the third, that's the one that's owned by you. Okay.
Owned by me.
Yeah.
And if I go back, the one that I created for Prakhar is right down there. So
Okay.
so it gave me my personalized results, basically all the issues that are relevant to me as well.
Yeah. And the reason Prakhar is so far down is because there's probably a great many issues that you actually own that have a lot to do with fine tuning and embedding models.
Absolutely, yes.
Yeah. Okay. Very nice. And so basically, not only do you get the exact issues you just created, but you get several other embedding model fine tuning related issues that you're probably working on at this moment, or perhaps are prioritized and on your plate. So there's probably like 8 or 9 of those before you get to Prakhars, which is also part of the result set, but it's just not as relevant to you in a hyper personalized setting.
Yes, yes.
Okay. Fantastic. So that's, I guess we got to see a little bit of personalization. I know there's a lot more in terms of using context. When you talk about, especially when you're looking for answers, popularity matters, recency matters, ownership matters, who creates the content matters. And it also matters what work you're doing at this moment in time, or what product you're serving, or what customers you're working with, and so on and so forth. So all of these pieces, I think they give way to a more hyper personalized result in our system. So we'll talk maybe about that in a separate conversation. So looks like we've covered quite a bit of ground here, Prateek. Is there anything else you'd want to add?
I think that would be good for today, and maybe for the next live stream, we can even deep dive into our more personalization piece.
Yeah, I think it'd be good for us to talk about the personalization, maybe fine tuning of models on the embedding space. We could talk a little more about what it took for us to scale open search. We could probably talk a little more about just the specific topics around the metrics that we've been paying attention to, and how we generate data sets, which I think is also a very specific and very interesting skill for people to learn from. And again, folks, please join us on the Discord server, and we can have a better discussion around some of these topics. They obviously deserve a lot more time than this, but for today, this is all the time we had. Appreciate everybody's time. Thank you for joining us, and we'll see you next time. Take care.
Thank you.
Bye.